Now that we've generated the Gerber files for our circuit diagram, our PCB, we're ready to set up the carve itself. We're going to use a tool called Carbide Copper, which is just copper.carbide3d.com. And this is a nice tool that is able to take these Gerber files and basically prepare the G-code for a CNC mill to carve away the copper to isolate the different traces, as well as to drill the through holes so we can seat our components and solder them onto the board. And I think one of the greatest things about this tool is that it's not machine specific. Although Carbide makes their own CNC mills, we don't happen to have one. We're going to be working with a Carvey, but really you could be using this with any number of mills. There is a tool selection later on that basically you just have to choose a tool that's going to match what you can put into your mill, and then other than that, we should just be able to go. So I'm going to put these files to the side for a second, and we're going to begin with setting up the material for our carve. Now, I know in inches that I've got a 6x6 plate, right? And that's what we'll be using for our class. And then I believe the material thickness is 1.58 millimeters. I'm just going to switch units. And this, I think, is our standard PCB thickness, at least for single-sided copper-clad board. And for job type, we can do top side only or bottom side only. If we're choosing bottom side only, it means the copper will be on the underside, and we'll put all of our components, plug them in through the top side. Now, this actually does mean that our circuit needs to be mirrored, since we won't be plugging them in on the same side that you see the copper. This matters for components that have more than 2 leads, right? If there's only 2 leads, we can just flip the component itself. But any ICs or even potentiometers, for instance, it may change the circuit significantly if we're plugging them in from the opposite side of the board. So if we leave job side or job type to bottom side only, it's going to automatically mirror the traces that we're going to load to carve around. So we'll leave that on bottom side only. This is going to be a single side PCB, which is certainly the simplest for manufacturing them ourselves. Now our second step is to upload the Gerber file that has the traces, the signals. And if we choose file, I guess the way that I made it in Fritzing was I said that all of the traces were on the top, even though I guess they're going to be on the bottom. So I'm going to look for copper top, and if I double click to load, we should see that we've got a bunch of traces here. If we zoom in, we can see the traces. We got no holes that are drilled, and then we also see these outlines that are giving us a sense of how many isolation layers we're going to use, basically how many passes around the outside perimeter we're going to use. And we also can choose what type of tool we're going to use. Now, these are all tools, specifically the carbide cells, but I do have a 0.1 millimeter 60-degree V-bit, so that's what I'm going to be using. And with a V-bit, the deeper it carves, the wider it carves, and I found in my test runs that 2 isolation passes is good enough. And in fact, it probably carves more than it says it's going to here. And that might have to do with how well calibrated your CNC is. If you've got something that's super dialed in, you probably can run 3 and you're fine. If there may be some margin for error, you might find that running 2 will leave you with more traces. Basically, if it over drills, the traces are going to be thinner and thinner, and if they get too thin, you might find a spot where it's no longer connected. So I found 2 is a good amount of isolation, and then we'll move on to the next step. I'm going to zoom out one more time. You may notice that this isn't in the very bottom corner, and that's again because we were using the Carvey. There is a smart clamp that is in the very bottom left corner, and so we really don't have workable, millable area without running into that clamp for the first inch to the right and the first inch from the bottom. So I made sure that when I was designing this in Fritzing, that I made my board outline have a padding of about 1 inch so that it would sit in this location. Okay, and so if yours doesn't look like this, call me over and I'll help you get to the place where it is, but there's no point in going further if your drawing is situated down here because we won't be able to actually mill it. The third step is to add the drill holes to our mill. If I go back to choose file, there should be another file. It will actually be a text document, something underscore drill.txt. And if you pick this and open it, it will not initially look like it's going to do anything. And this initially threw me for a loop. And what it's waiting for is a non-custom tool. Now each of these are small PCB drills that have a really small diameter that is fine for basically plunging in and making a large enough hole to put our components through. And we've got actually a number of different sizes. I have one loaded that's a 0.8 millimeter that in my first test worked just fine. So I'm going to choose that again. And when I make that choice, we should be able to see then that we've got drill holes showing up where each of those component leads should be plugging in. I'm going to hit next, and the board outline file is for cutting the board itself out. We will manually cut this. We'll bring it into the wood shop and use maybe a scroll saw or a band saw or something like that, and we'll be able to separate this from the board using a different technique. Okay, so we could basically skip this step. We're going to skip the area rub out step as well. And then when we come to the output, so this is going to try to give us a little bit of a simulation of what the passes are going to do. We're going to save it as separate G-code files because we're using two different tools and our CNC router doesn't have any automatic tool changing in it. So we'll have to run two separate operations, the isolation passes and then the drills. So we'll say save G-code as separate files. And then if we were to open this file up and extract these files so we can see them and interact with them, these NC files are what we call G-code. So if we were to look at the contents, it really is just a bunch of numeric instructions that are telling the mill where to go in terms of X, Y, and Z positions. Also some instructions about how fast the spindle should be spinning and basically retraction height. So there's drilling moves, there are non-drilling moves, and it's just a really long list of those G-code instructions. I found in my first test that in the drill code we actually had some errors, and it was all of these T something lines, T608, and then if we keep working our way down, there's T609, T100, T101, and actually I haven't been able to figure out what those G-code instructions mean, but our particular router software doesn't know what they are, and so we get an error. So before you can actually run this, you just need to go through and delete those T instructions. Everything else can stay. I just hit Control S to save, and then these files are ready to go. Now the final step before we move on to the actual routing software will be to look up an NC viewer. And if we click on this and choose the first option, this is a G-code viewer / simulator, and if I say I want to open a file, I'll have to navigate to where I just extracted the actual NC files. And if I choose, let's say, the bottom contour, we should be able to see something that from the origin is spaced off about an inch. And if you were to hit play, you'd be able to see a simulation of how this is actually going to be routed out. The main thing we're looking for is just that we have a path that matches the shape of our PCB. And if things are looking good, we're able to move on to the next step. We can try both of the files just to double check. So we look at the drill. This one will look a little bit different. It won't have any path lines along the bottom. It'll just be travel moves and then vertical drills. All right, and that's a pretty quick one to simulate our way through. So if both of those steps are looking good, we're ready to hand those two files in, and we'll move on to the actual routing and creation of the PCB.